Hey everyone, welcome to DesignLab Builds, a new series where we show you projects that we're developing here at Supplyframe's Design Lab in order to inspire your entries into this year's Hackaday Prize. Challenge 4 is Climate Resilient Communities, where we're tasking entrants to develop hardware solutions that will either help communities become more resilient to weather and climate disasters and/or help collect useful information about the environments around us. Let's learn all about this open source air quality sensor for urban river environments from our product development engineer, Giovanni Salinas.
This is the newest project we've been working on, Climate Resilient Communities. And this air quality detector has been designed with two things in mind. Number one, that they may be used indoors or outdoors, and number two, that they should be easily shareable and distributed. You can see on the inside that it has ample space, and the reason for that is that, well, you need air flowing through it constantly. And in addition to that, we need a much larger battery than what you're seeing. This was just for testing, so don't mind the battery. And inside we have three main components. Number one is the rack board by Helium Foundation. This board is the brains and the communication. You can see here we have the LoRaWAN module together with the GSM module, which allows us to communicate to a cellular network, and the weather sensors. Additional to the air quality sensors that you find on the rack board, we created, with the help of Eduardo Contreras, another board with an MIC sensor. And this little sensor is very interesting because it detects NO2, carbon monoxide, ammonia, ethanol, and other toxic gases that if you find them in the air, it means that someone is dumping them on the rivers or on the urban bodies of water. Okay, so let's talk quickly about the design. We have on the front solar cell, and then this solar cell has to connect to the inside. These are very interesting because they are shipped just as a foil. It doesn't have many more connections. So it happens that this is a bus, and what you do is you solder your own wires with the length that you need. So once you have your solar panel on it, we have a climate resistant, UV resistant acrylic. We tried using ABS and ASA. We had some problems with it, probably because of the weather. That would be the ideal material. In this case, we just used PLA, which is much more forgiving, but you can use either of those. If it goes outdoors, we definitely recommend using ASA. The unit is designed in a way that you can put it standing on a surface, no problem, or it has two handles. And the reason we added these handles is to make sure that you could fix it on a post. Could be a light post, could be a tree, anywhere that is near to your urban body of water that you want to monitor. Okay? So you can see the angles. That is to prevent rain or dust to accumulate on it. Once this unit is functional, is operational, it will constantly monitor the air quality in the surroundings and send you notifications every time the levels of toxic gases are too high, are hazardous for humans, for breathing.
This build was unique in that we got to develop a workshop with Helium to take to our community abroad, and it was so awesome to see the enthusiasm from engineers and students in Barcelona. Thanks for watching this episode of DesignLab Builds. We hope we inspired you to get outside and learn more about your environment. To learn all about this year's Hackaday Prize, be sure to check out hackaday.io and any of our social channels to learn more about updates and more DesignLab Builds. Thanks so much to our sponsors, Helium, Supplyframe, and DigiKey for making this build possible.